Hi everyone, let's start with unit 18.3. We'll be looking at pH curves to begin with. Now, we're going to be looking at how the pH changes when we do a titration. Now, there's different kinds of titration. We can have a titration where you have a strong acid and a strong base, the typical titration that you have done, so HCl and NaOH titration, strong acid, strong base. We'll also see weak acid, strong base. For example, if you have a weak acid like ethanoic acid and a strong base like NaOH. You could also have a strong acid, weak base, so a strong acid, for example, HCl, and a weak base like aqueous ammonia. Or you could have a weak acid, weak base titration. You could have ammonia and ethanoic acid. So these are just examples, and we'll see how the pH values changes during the titration. Now, we've done titration using indicators, but some of you have also done their practicals, especially your IA, with a pH meter. Now, the pH meter can be used here while a titration is being done, and the pH meter is going to record changes in pH that is happening, and from this we're going to have a pH curve that shows how the pH is changing during the titration. Now, in this unit we're going to have some terms that you have to know. Now, these are terms that will come across during this part of the unit, and we're going to see what they mean as we go along. Now, let's see the first titration, strong acid, strong base titration. So we have HCl reacting with NaOH. And here you have a titration where you have 1 molar of NaOH, which is added to 50 centimeter cube of 1 molar HCl. This means that the HCl, so we have 50 centimeter cube of it, which means that this is from the conical flask, and that the NaOH is actually from the burette. So as the base is being added to the acid, we're going to be recording the pH of the solution here. Normally, we will not be using a conical flask because everything might not fit in a conical flask. So we usually use a beaker when we need to put in the pH sensor in here. So initially, while we're starting, the pH meter will just be recording the pH of the HCl, of the 50 centimeter cube of 1 molar HCl. So initially, there's no NaOH that has been added yet. So we start the process. The first pH values that we record is the pH of the HCl only. So let's see what pH will be recorded. So as we begin with, the 0 centimeter cube of NaOH that has been added. So the only thing present is 50 centimeter cube of, so the initial concentration of the H plus is 1 molar, so 1.0 mole per dm cube. Hence, the pH at this point is 0. So the starting pH will be 0. Now, as we're starting to add NaOH, the pH is going to change. So we'll have more of NaOH being added, less of acid, but the acid will still be in excess. So you will have the acid and you will have the salt that will be formed, so that in the flask we'll have excess of HCl, and so all NaOH is converted to NaCl. So we'll have the salt and then we'll have water. So you have excess of HCl. So the solution is still expected to be acidic. So let's calculate the pH now. So we're adding 25 centimeter cube of 1 molar NaOH. So here we still have excess acid in the flask. So initially we had 50 centimeter cube of that HCl. So let's calculate the number of moles of acid in 50 centimeter cube of HCl. So number of moles is concentration times volume. So concentration times volume. So that gives us 0.05 moles of H plus that was initially present. Now to this we have added 25 centimeter cube of NaOH. Let's calculate the number of moles of NaOH that has been added. So number of moles is concentration times volume. Now all the NaOH that is added is actually going to react with the HCl. So all of this is going to react, but it's not going to use up all of the 0.05 mole HCl. Remember from the equation here, it's 1:1 ratio, which means that this number of moles of NaOH is going to react with only 0.025 moles of HCl. So which means that out of this, there's going to be only some left. So now we have only 0.025 moles of HCl that is left. Now, for us to calculate the pH of this solution, we need a new concentration of H+. So we have a new amount of moles of HCl, and this is present in a new volume. So what's the new volume? So we initially had 50 centimeter cube of acid, and to this we have added 25 centimeter cube of NaOH. So what's our new total volume? So that's 75 centimeter cube. So in 75 centimeter cube, we have a new amount of HCl present, actually H+, because HCl is going to give us H+, which means that the new concentration of H+ is going to be the number of moles of H+ divided by the volume of H+. We're going to times 1000 because it's in centimeter cube. So the new concentration of H+ is this. Now from the H+ concentration, we can get the pH value. So pH is minus log of H+. So when 25 centimeter cube of NaOH is added, the new pH is now 0.47. So there is a very small change in pH. Let's continue now with 49 centimeter cube of NaOH added. Let's calculate the pH again. Pause the video, try to calculate the pH, and then come back to see if you get the same calculation, the same answer. So the initial number of moles of acid is still 0.05. You calculate now the number of moles of NaOH added, so concentration times volume. Then you calculate the amount of acid left. So out of 0.05, because the mole ratio is 1:1, so 0.049 moles is going to be reacted. So this is the number of moles of H+ left. Now this is present in a new volume. So 50 plus 49, so I have 99 centimeter cube. This is present in that new volume. And we can find the concentration of H+. So concentration is number of moles divided by volume. So now the pH is 2. So as you can see, even if we add 49 centimeter cube of NaOH, the pH changes by a very small amount. Now let's add that one last centimeter cube until neutralization is complete. So now once all the acid has been neutralized, because here we have NaOH and HCl, which are in the ratio 1:1, which means that equal volumes of equal molarity will neutralize each other. So all acid has been neutralized, so the pH of the neutral acid is going. Now if we add excess of NaOH, we continue the titration until we have excess of NaOH. So we have 1 centimeter cube of excess NaOH. So number of moles is concentration times volume. So that's the number of moles of excess NaOH that we have. Now this is present in a new volume. So I have 51 NaOH, which is present in HCl, which we already had 50 centimeter cube of it. So 101 centimeter cube of new solution of that solution, and from this we can calculate the concentration of OH minus, concentration of moles divided by volume, and here we can get the concentration of OH minus. From this we can get the POH. Now from the POH, now we can get the pH is 12. So you have the excess of NaOH. Now all this information can be represented, can be seen from the pH curve that we get when we do the titration. So this is a typical curve for strong acid, strong base titration, where you get the equivalence point over here, where you have that maximum gradient point. So at pH 7, for all strong acids, strong bases, you will have that neutralization point at pH 7. And here you have the equivalence point, that is the volume of titrant that is required to neutralize the analyte, just neutralize the analyte, so there's no excess of anything. And at first here, so let's label this point 1 and point 2. So at first, at number 1, we have only the acid. At number 2 here, we have a small amount of base that has been added, so we still have excess of acid, but the change in pH is very gradual. And then we have a sudden jump in pH. We'll label this region free, a sudden jump in pH at the equivalence point. So you can see that the pH changes rapidly from 2 to 12, and after the equivalence point you have that region in the region in the curve that flattens out to a higher value until eventually, when all the base is in excess, we have the pH of the base here. And here you see that the pH at equivalence is 7. This is for strong acid, strong base. Now for strong acid, strong base, there is no buffer region. We'll see later on what is a buffer region. So the following points can be deduced from the graph. Now in this case, we have NaOH, which is added to the acid. So we have a base added to an acid. But if you have an acid which is in the burette, which is going to be added to the base, then the shape of the curve is going to be slightly different. We'll still have that equivalence point at pH 7, but now the starting pH is going to be the pH of the base, and then it's going to go down, and then it will flatten down at a lower pH. But at equivalence point here, we'll still have the pH to be 7. So these are how the two graphs would be, slightly different in the way they start and the way that they finish. So strong acid added to a strong base will look like this, and strong base added to a strong acid will look like this.